Okay, we're moving on to sex-linked traits problem number 3. People who are colorblind can find it difficult to identify and distinguish between different colors. There are different types of color blindness. Red-green color blindness is caused by a recessive allele found on the X chromosome. And just so you know, people who have red-green color blindness cannot tell the difference very easily between red and green. They look like they're the same color to them. So a couple is going to have 2 daughters. The mother is colorblind and the father is not. You're going to use the letter big B to represent the colorblind allele. So we're going to figure out the genotypes of the parents and do our Punnett square, and then we'll answer the question. So if the mother is colorblind, but the father is not, that means she's going to have 2 lowercase b's because she has to have 2 copies of that recessive allele. And then the father is going to have the capital B because he doesn't have the condition, and he's going to have the dominant allele. So if we set up our Punnett square, this is how it will look. And then we'll fill it in. You can see we've got 50% chance girls, 50% chance of the boys. Clara reads the information above and states that it is impossible for any of their daughters to be colorblind. Explain whether or not she is correct. Use this Punnett square to support your answer. So she says it's impossible for the daughters to be colorblind. Well, let's look at the daughters. Here are the 2 possible combinations that the daughters can end up as. You have a capital B, lowercase b for this one, a capital B and a lowercase b for this one. Because color blindness is carried as a recessive allele, you have to have 2 copies, 2 lowercase b's to be colorblind like the mother is. And so these 2 daughters are going to both have normal color vision because they have that capital B to mask the lowercase b. So these daughters will not be colorblind. And so Clara is correct. Both daughters have inherited the father's normal allele, which masks the recessive colorblindness allele. If they had a son, they would have a 100% chance that the son would be colorblind because they're receiving a colorblind allele, doesn't matter which one, from mom.